Hello, everybody. Good afternoon. So today we're going to practice for the chapter, or we're going to go over the chapter 7 review in the third grade book. We're on page 311. So let's get started. Number 1, Ming divided 35 marbles between 7 different friends. Each friend received the same number of marbles. How many marbles did Ming give to each friend? And so it's showing us a division problem. 35 represents the total number of marbles. 7 is the 7 different friends. And it's going to equal the quotient, which would be how many marbles each friend gets. And they're showing us that a related multiplication fact to solve this problem would be 7 times what is 35. So let's go ahead and think about that. Well, we should know our 7s, but we can always make a list of them, right? 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. And 7 times 5 is 35. Now, if I had just known that 7 times 5 was 35, I wouldn't have had to use this strategy at all, okay? I could have just circled 5, okay? But remember, Chapter 7 was all about using strategies to help us divide, okay? But if we have those basic division facts memorized and it doesn't tell us to draw something, just answer it. Okay, number 2. Mrs. Connor has 16 shoes. Select one number from each column to show the division equation represented by the picture. So 16 would be the dividend. It's the total number of shoes she has. Now, we have two choices for the for the divisor. We could have divide by 2 because there's 2 in every pair, or we can be divided by the number of pairs of shoes, or the number of groups of shoes. 1, 2, 3, 4, 5, 6, 7, 8. So let's look at our divisor. Okay, so I don't see 8. So it must be using 2. So 16 divided by 2. Okay, so the 2 is the amount in each pair. How many pairs? Well, the pairs has to be 8. So the quotient, or the answer to the division problem, has to be 8. Okay, number 3. 20 boys are going camping. They brought 5 tents. An equal number of boys sleep in each tent. How many boys will sleep in each tent? So we have 20 boys, 5 tents. How many will sleep in each tent? Well, we can use these 5 tents that they've already set up for us as our groups. Normally we could draw circles, right? So the division problem would be 20 divided by 5 groups. 20 divided by 5 groups equals what? Okay, well, let's put one counter in each tent. All right, so that's 5 of the boys. And I'm going to keep adding one boy to each tent until all 20 are in a tent. Okay, so we have 2 in each tent, so we have 10. 15, 20. Okay, so that makes sense because 5 times 4 equals 20. So there's 4 boys in every tent. All right, 312. Circle a number for the unknown factor and quotient that makes the equation true. So we have a related facts here. We have 4 times something equals 28, and we have 28 divided by 4 equals what? Well, I know that 4 times 5 equals 20. So 4 times 6 would be 24, and 4 times 7 is 28. So 4 times 7 equals 28, and 28 divided by 4 equals 7. Number 5. Mrs. Walters has 30 markers. She gives each student 10 markers. How many students received the markers? And so we show here the strategy of repeated subtraction. So the original problem would be, so it says write a division equation to represent the repeated subtraction. So she has 30 markers total, and she's going to divide by 10. How do I know she's dividing by 10? Because we subtracted 10 each time. So 30 divided by 10, she subtracted it 1, 2, 3 times. So 3 students received markers. Number 6, complete the chart to show the quotients. So remember, 27 divided by 9 is how that's read. 27 divided by 9. And since I'm dividing by 9, the opposite would be 9 times something. And so I know that when I multiply a factor by 9, that the factor that's being multiplied has to be 1 greater than the tens place of the product. So if the product here is 2, or 2 tens, the factor has to be 3. So 9 times 3 is 27. So 27 divided by 9 is 3. So 9 times what is 36? Well, again, look at the tens place. The factor that we multiply by has to be 1 greater than that, so 4. 9 times what is 45? If we focus on the tens place, that tells us that the factor that's being multiplied by 9 is 1 greater than the 4, so it's 5. And the last one, 9 times what equals 54? So 5 is in the tens place, so the factor is going to be 1 more, or 6. Okay. For 7a through 7e, select true or false for each equation. Is 12 divided by 6 2? Well, if we have 6 groups and we put 2 in each group, does that equal 12? 2, 4, 6, 8, 10, 12. Yeah. It would have been just as easy to say 6 times 2 is 12. So that's true. 24 divided by 6 equals 3. So again, let's have 6 groups. And we're going to put 3 into each group. And if that's true, it should equal 24 counters. Okay, so let's count them. 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is 18. I was supposed to get 24. So no, that's false. I would have to put 4 in each group. 30 divided by 6 is 6. So let's see. I have 6 groups. They want me to put 6 in each group. So that's 6, 9, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Oh, that's 30 already. I haven't put any in the last circle. So no, that's not going to be right. That's 36. 6 times 6 is 36. So no, false. 6 times 5 is 30. 6 times 7 is 42. Well, if this is 6 times 6, if I put 1 more in each group, right, this is saying 6 groups of 7. So 37, 38, 39, 40, 41, 42. That's true. Okay. 6 times 7 equals 42. And is 48 divided by 6, 48? Well, if 6 times 7 was 42, 6 times 8 is 6 more than 42. And 6 plus 2 is 8. So yes, 48. All right. Page 313, number 8. Alicia says that 6 divided by 2 plus 5 is the same as 5 plus 6 divided by 2. Is Alicia correct or incorrect? Explain. Okay, well, order of operations tells us multiply and divide left to right, then add and subtract left to right. So I have to divide first, and then I'm going to add the 5 second. So in this one, I'm going to divide first, and then I'm going to add 5. Yeah, she's correct. Okay, so it's the same thing. Just switch the order of the addition for the 5 to the front here instead of after. But based on order of operations, you have to divide first. So it doesn't matter where that division problem is. Okay, if the numbers are the same and the operations are the same, has to be the same. Number 9. Keith arranged 40 cars in 8 equal rows. How many how many toes? How many toy cars are in each row? 40 toy cars, 8 equal rows. Well, this seems to be a great candidate for an array. So let's make one row of 8. All right, so we have one row of 8. Now I keep adding 8 cars to the rows until I get to 40. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. So we have 8 rows of 5. So how many toy cars are in each row? 5. 10. Bella made $21 selling bracelets. She wants to know how many bracelets she sold. Bella used this number line. $21. She wants to know how many bracelets she sold. So what are we dividing by? It looks like 1, 2, 3. 1, 2, 3. 1, 2, 3. So we're repeatedly dividing by 3. So the bracelets cost $3 per bracelet. So how many times did we subtract 3? 1, 2, 3, 4, 5, 6, 7. She subtracted them. Yes, she sold 7 bracelets. So it's 21, the total that she made. Divide by $3, and that means she sold 7 bracelets. Number 11. Each picnic table seats 6 people. How many picnic tables are needed to seat 24 people? Explain the strategy you use to solve the problem. All right, so every table seats 6 people. We need enough for 24 people. Explain the strategy. All right, well, if you remember from a little bit earlier, there was boys going camping, and there was a picture of tents. Well, why don't I just draw Oh, no, I'm sorry. That's not what we want to do. They didn't tell me how many tables. I have to figure out how many tables. So I'm actually going to make 24 counters. All right, so I'm making 24 counters, and I need to put them in groups of 6. Every group of 6 will be one table. All right, so 1, 2, 3, 4. So 4 tables. Okay, I drew 24 counters and then circled groups of 6. So basically, I was using equal groups. Number 12. Finn bought 2 packs of stickers. Each pack had the same number of stickers. A friend gave him 4 more stickers. Now he has 24 stickers in all. How many stickers were in each pack? Explain how you solved the problem. Huh. Okay, so there's a lot there, but let's take it slowly. 2 packs. So he bought 2 packs. Each of those packs had the same number of stickers. A friend gave him 4 more. So he didn't buy those. He was given those 4. Now he has 24. How many stickers were in each pack, and explain. Well, we can draw a picture and act out the problem, or we can use our knowledge of operations, order of operations. So I'm going to do both so you see. Okay, so he has 24 right now. So I'm going to draw 24 counters. 4, 8, 12, 16, 20, 24. So he has 24 now. His friend gave him 4. Okay, so before his friend gave him the 4, he didn't have 24. So we need to take these 4 and subtract them. Okay, so now he had 4, 8, 12, 16, 20. He had 20 stickers to share with, or that came in 2 packs. Okay, well, 2 times what is 20? 2 tens is 20. So each pack had 10 stickers. what did I do to solve that problem? I drew 24 counters to show how many he has now. I had to cross out 4 because he didn't buy those. So he purchased 20 stickers in 2 packs. 20 divided by 2 equals 10. Okay, so what would that look like if I just wrote an equation using order of operations? We have the 24, and we have to subtract 4. And then we divide it by 2. And technically, we'd have to put parentheses around that because we have to do the subtraction first in this case. Okay, so it's not really something that we've talked about in solving this problem. So I probably would just go with the picture, but this is what it would look like. Okay, 24. Remove the 4 he was given, and then divide it by 2. Okay, remember parentheses is what we have to do first in that order. All right. Anna used 49 strawberries to make 7 strawberry smoothies. She used the same number of strawberries in each smoothies. How many strawberries did Anna use in each smoothie? Okay, 49 strawberries, 7 strawberry smoothies. Well, what if we drew kind of like the 7 smoothies to represent our groups? 2, 4, 5, 6, 7. She made 7 smoothies. She has 49 strawberries to share with those 7 smoothies. So 1, 2, 3, 4, 5, 6, 7. So I put 1 strawberry in every smoothie. And I'm going to keep adding 1 until I get to 49. All right, so that's 14. 7 plus 7 is 14. 14 plus 7 is 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. So how many strawberries are in each smoothie? 1, 2, 3, 4, 5, 6, 7. 7 strawberries. And we could have also just as easily solved it like this. 49 divided by 7 equals S or something, the number of strawberries. Okay. And we would have said 7 times 7 equals 49. All right, 14A through E. Use the order of operation to select true or false. Okay, so division is first, addition second. First, second. 81 divided by 9. Again, I know that when I multiply 9 by a factor, that factor is going to be 1 greater than the tens place. So this is 9. 9 times 9 is 81. So 81 divided by 9 is 9. 9 plus 2, that does equal 11, right? 9 plus 2 is 11. So 11 equals 11. This is a true equation. 6 plus 4 times 5. Well, multiplication, addition. We're going to multiply first. We're going to add second. 4 times 5 is 20. 20 plus 6. 20 plus 6 is 26. 26 equal 50? No. So that's false. 10 plus 10 divided by 2. So we're going to divide first, add second. 10 divided by 2 is 5. 10 plus 5 is 15. 15 equals 15. That's a true equation. 12 take away 3 times 2 equals 6. So again, we're going to multiply first, then subtract. So 3 times 2 is 6. 12 take away 6 is 6. That's true. And the last one, 20 divide by 4 times 5. So we're going to multiply first. Oh, no. Okay, so all we have is multiplication and division in this problem. So the order of operations, the rule for that says multiply and divide left to right. So that's all we have is multiplication and division. So we're going to divide first. So 20 divided by 4 is 5. And 5 times 5 is 25. 25 does not equal 1. So that's false. Okay, 15. A flower shop sells daffodils in bunches of 9. It sells 27 daffodils. How many bunches of daffodils does the shop sell? 27 total, bunches of 9. All right, so I drew 27 daffodils using counters. Let's double check it, make sure I have 27. 3, 6, 9, 12, 15, 18, 21, 24, 27. Now, I'm going to put them in bunches of 9. So I need to circle groups of 9. 3, 6, 9. 3, 6, 9. 3, 6, 9. So how many bunches of 9? I have 3. So 27 divided by 9 equals 3. 9 times 3 is 27. Okay, 16. Aviva started a table showing a division pattern. 20 divided by 10, 30 divided by 10, 40 divided by 10, 50 divided by 10. Well, how many 10s does it take to equal 20? So we're asking this. 20 divided by 10 equals what? 10 times what equals 20? 10 times 2 is 20. So if 20 divided by 10 is 2, this is a pattern, so 30 divided by 10 is 3. 40 divided by 10 is 4. 50 divided by 10 has to be 5. What is 20 divided by 5? 20 divided by 5 equals what? Well, 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. And 5 times 4 is 20. Okay. Oh, so it's the quotient's twice as much when I divide by 5. I remember that. Remember when we divide by 10 and 5, that when you divide a number by 5 instead of by 10, the quotient will be twice as much as when I divided by 10. So 30 divided by 5 is 6, because it's twice as much as when I divide by 10. What's twice as much as 40 divided by 10 if I divide 40 by 5? 8. And now we also notice a pattern here. 4, 6, 8. It's counting by 2s. 10. So 50 divided by 5 will be 10. Complete the table. We did. Compare the quotients when dividing by 10 and when dividing by 5. Describe a pattern you see in the quotients. Okay, so when I divide by 5 instead of by 10, the quotient is twice as much. Okay, so find the quotient for A. 70 divided by 10. So if we go back to this and we start to notice a pattern, 20 divided by 10 was 2. So basically it was 2 divided by 1. 30 divided by 10, 3 divided by 1 gives me 3. 40 divided by 10 gives me 4. 40 divided by 10 gives me 4. 50 divided by 10 gives me 5. Then the next one would be 60 divided by 10 is 6. 70 divided by 10 is 7. So if 70 divided by 10 is 7, then what would 70 divided by 5 be? Well, it would be 7 times 2. Because when I divide a number by 70 by 5 instead of by 10, it's going to be, the quotient is going to be twice as much. So 7 times 2, 14. The quotient will be twice as much as A. And 17. Ben needs 2 oranges to make a glass of orange juice. If oranges come in bags of 10, how many glasses of orange juice can he make using 1 bag of oranges? So he's going to have a bag of 10 and he needs 2 oranges to make a glass of orange juice. Well, okay, so he has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. He has 10 oranges because they came in a bag of 10. He needs 2 oranges to make 1 glass. Okay, so that's 1 glass of orange juice. 2, 3, 4, 5. So he can make 5 glasses of orange juice from 1 bag of oranges. So I could basically say 10 divided by 2 equals 5. Page 316, number 18. Select true or false for each equation. Is 0 divided by 9 0? Yeah, any 0 divided by any number is 0. Is 9 divided by 9 1? Any number divided by itself is 1, so that's true. Is 27 divided by 9 4? No, that's going to be false. Because remember, when we multiply by 9, there's a pattern that the number that I multiply by 9, the product will be 1 less in the tens place than that factor. So 36, so false. 54 divided by 9 equals 6. 9 times 6 equals 54. Is that true? Yeah. I'm multiplying 9 by 6. It's going to be 1 bigger than the tens place of the product. The tens place is 5, so the factor is going to be 1 bigger. So that's true. Is 90 divided by 9 9? No. 9 times 9, 1 less than 9 is 80. Would be 80 in the tens place, so 81. So false. 9 times 10 is 90. Okay. 19. Ellen is making gift baskets for friends. She has 16 prizes she wants to divide equally among the baskets. How many prizes should she put in each basket? Okay, so the gifts are going to 4 friends. So she's going to share those baskets with 4 people. And so she has 16 prizes to share with 4 people. So our problem is 16 shared with 4 friends. Okay, well, so those are the 4 friends, and you have 16 prizes. 1, 2, 3, 4. Keep adding 1 to the circles, to the groups, until you've used all 16. That's 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 4 prizes in each basket. And that makes sense. 16 divided by 4 is 4. 4 times 4 is 16. Number 20. Emily is buying a pet rabbit. She needs to buy items for her rabbit at the pet store. Okay, so A. She needs to buy a cage and 2 bowls for $54. The cage cost $40. Each bowl is the same. What is the price of 1 bowl? Okay, so she buys a cage for $40 plus 2 times something equals 54. Or we can say 54, take away 40, equals 14 divided by 2. So if I subtract 40, the cost of the cage, from the total amount she spent, that leaves $14 for the bowls. She bought 2 bowls. So 14 divided by 2 equals $7. So what did I do? Well, I subtracted 40 dollars from 54 to get $14. The $14 is what was spent on the bowls. $14 divided by 2 equals 7. So each bowl was $7. And part B. Emily also buys food and toys for her rabbit. She buys a bag of food for $20. She buys two toys for $3 each. Write one equation to describe the total amount Emily spends on food and toys. Explain how to use the order of operations to solve the problem. All right, so she buys a bag of food for $20. She also buys 2 toys for $3 each, equals C, the cost. So 2 toys, $3 each, plus 20. So it doesn't matter. I could have 2 times 3 plus 20. Okay, there it would be the same thing. Okay, because we have to multiply first. So multiply 2 times 3 first. Because in order of operations, you'd multiply then add. So 2 times 3 equals 6. Then add 20 to 6 to get $26. All right, guys. So that's it for Chapter 7. The next time we meet, we'll be starting Chapter 8, and it'll be our discussion and study of fractions. So until then, may the numbers always be in your favor.